idea of filling out the structures while you're watching the video, hopefully you got all those, because I'm going to assume you did. And then the ones I wanted to add were from the very first video, which are that these are not functional groups, but you'll see these a lot in these structures. One is the benzene ring. So the benzene ring is this 6-carbon ring. Looks like a hexagon, 6 carbons with 3 double bonds. So it's written like this, or sometimes you'll see it written like this, where it's 6 carbons with a circle inside of it. And so the circle means that you have the 3 double bonds that have resonance and they can move positions. Remember, resonance is when you can swap a double bond with a single bond in the structure, but you have the same chemical formula. There's also the alkane, which is just a double bond. Okay, or the alkyne, which is a triple bond. Okay, and so we saw those in the last lecture. But we will see double bonds and triple bonds and benzene rings in the structures of molecules like drugs and medicines. And you just saw that one that I showed you a lot. I showed you a lot of structures in the previous videos, but we'll see a lot more in the coming lecture next week. Okay, so we have these molecules. Let's start with the simple molecules that are organic molecules with functional groups. And we want to figure out the chemical name. So using the same steps as the first set of these where we did not have functional groups, but the idea is writing a chemical name by basically figuring out all the different parts of this organic molecule. So this is a review of the process, but we're including those functional groups now, okay? And the functional groups have those name endings. So we have to change the name endings in general when you have a functional group. So changing those name endings to represent the functional groups. And here are those name endings, these ones. Okay, so make sure you have those handy. Make sure you have this sheet handy. Okay, so first of all, you are given the structure. That's the structural formula. And you want to find the longest continuous chain of carbon atoms. And that's going to be the parent chain. So for this first one, the longest continuous chain are those carbons. So this is a 3-carbon parent chain. Okay, the other thing you notice on this is this OH group. This is a functional group. Well, what is that functional group? Based on, we know there's 7 possible functional groups, and this is an alcohol functional group. It's the OH group. Okay, so let's go back to, we found the longest continuous chain, and then I want to number the carbons in that parent chain, starting from the end closest to whatever's going on. It can be a double bond, a triple bond, a branch, and now we're adding closest to the functional group because that is something that's different. Just like a double bond or triple bond or branch is different, the functional group is something different, and you want the functional group to have the lowest possible number. Okay, so that's why you number from where there's something going on. So whether you number left to right or right to left, that functional group will be on carbon number 2. Okay, so that's carbon number 2 right there that functional group is coming off of. So in writing the name, you want to have the number, which is the location of the functional group. And this location of this functional group is on carbon number 2. So you want to start with the 2, the location of the functional group, as the name. And then when you're attaching a number to letters, you need a dash. Adding a dash to that parent name, and the parent name is based on how many carbons there are in there. If there's 3 carbons in the parent chain, this would be called propane. And so remember, you can use these for the 3 carbons, that's the propane. So remember to use this, the alkane family prefixes. So we've got Propane. And this is propane because it has all single bonds. Okay, that's what ANE means. And there are all single bonds in the parent chain. But then you want to take off that last E. So let's actually keep this, write this propane. It would be propane, except for that functional group. So remember that functional group. So you want to take off the last E. Whoops. I want this to be the last E off and replace that with the name ending for the alcohol, which is an OL. Okay, so basically we want to change this from 2-propane to 2-propan, keep everything but that very last letter. So that's minus the E, so crossed out that E, and then add the name ending for the alcohol, that OL. So this is going to be 2-propan and then OL. Okay, and that's the name of this structure here, 2-propanol. So that includes all the parts of this molecule, mostly just the propane with the functional group alcohol. Okay, so that's going on to the next one, is a 2-carbon parent chain. So this is the longest 2-carbon parent chain. And we want to figure out the name of that 2-carbon parent chain. When if you have 2 carbons, that would be called ethane. Okay, but there's a functional group here. So that functional group circling this functional group is the carbon double bond oxygen single bond OH. That's called the carboxylic acid. That's the carboxylic acid functional group. And we want to find the location of that functional group by numbering the carbons. And when you number these carbons, you're not numbering from left to right, but you're numbering from right to left, starting with this carbon because it's part of the functional group. You want to start and give the functional group the lowest possible number. Okay, so this is carbon number 1. So that carboxylic acid is on carbon number 1. It's part of the functional group, and it's also part of this carbon chain, those 2 carbons. Okay, so in writing the name now, we want to start with the number, the location of that functional group, which is 1, and then a dash to the parent name, which would be ethane. Okay, but just like the last time, I need to take the E off and replace that with the name ending for the functional group of the carboxylic acid. So the name ending for the carboxylic acid is ic acid. Okay, so we want to change this to ethanic acid. Okay, so I'll show you that here. I usually choose the shortest one. If you've got one or ketone, I choose I notice with the alcohol, I chose the shortest one. Okay, so for the carboxylic acid, this is 1-ethanic acid. And because you can get rid of ones, you could just call it ethanic acid. Okay, so you can add ones in or take ones out in a chemical name or a chemical formula. Okay, so the next example, we've got these 4 carbons are the longest continuous chain. So this is a 4-carbon parent chain. And so in this 4-carbon parent chain, you want to find the name of that, or the name of a 4-carbon parent would be the prefix but. It would be butane. And there's also this functional group. So in purple, what is the functional group with the carbon double bond oxygen? That's called a ketone. Okay. So when you have the functional group, you want to number this so that the functional group has the lowest possible number. So I'm going to number it from right to left. So that ketone is now on carbon number 2. Okay, so it's part of the main chain, and that is carbon number 2 of the main chain. So in writing the name of this, you want to lead with the number of the functional group location. It's on carbon number 2, and then add in the most of the parent chain name, leaving off the E, okay? And then what you need is the name ending for the ketone. So the name ending for the ketone functional group, the short one is what I like to use, is ONE. So instead of the E, you want to have butan and then ONE. 2-butanone is the name of that structure. Okay, next one is a 3-carbon parent chain. So this is a 3-carbon parent chain. And that 3-carbon parent chain would have the name with 3-carbon prefix, prop. They're all single bonds, so it would be propane. But there's a functional group here. So what is this functional group with a carbon double bond oxygen, single bond hydrogen? That's called an aldehyde. So an aldehyde, and then you want to find the number that aldehyde is on carbon number 1. The carbon is part of the main chain. So you want to have the lowest possible number. And it is also, that carbon is also part of the functional group that's in the aldehyde. So this aldehyde is on carbon number 1 of the main chain.
Hey, Professor, quick question. Why are we counting from right to left again?
Because you want the functional group to have the lowest possible number. If you went from left to right, it would be number 3.
Okay. Thank you.
Okay. So this is on carbon number 1. So you want to lead with the number 1 and then go into the parent name, which is propane, but remove that E. So instead of the E, you want the name ending for the aldehyde. And so go back and find the name ending for the aldehyde functional group, which is the short one. I use AL. So instead of the E, it's propane. Without the E, you want to add the AL name ending. And because you can take off the 1, you could just call it propanol. Okay. Let's see, the last here is a bent shape. And this is okay. It doesn't have to be straight across, but you're still looking for the 3 carbons that are all in one row. And this is a 3-carbon parent chain. So that 3-carbon parent chain would be called propane. Okay, but there's a functional group here. This functional group here is the carbon double bond oxygen. That's called ketone. Okay, we saw that before. And you want to number this so that the ketone has the lowest possible number. And whether it's left to right or right to left, that ketone is going to be on carbon number 2. So now lead with the number where the ketone is located. That's on carbon number 2. And then go into the parent name, which is propane. Except for, don't have that E. You want to change the name ending to represent that there's a ketone there. So this name ending is ONE for the ketone. Okay, we saw that ONE name ending for the ketone before. And so that's 2-propanone is the name. So in just looking at the name ending, it quickly tells you what the functional group is in the molecule. And that's good because the functional group is what imparts a function. And so that is important in when molecules get more complicated. And so we'll see that in molecules that are bigger, they have lots of other carbons, lots of other things going on, but the functional group, the presence of just that one nitrogen might be why your molecule is called methamphetamine, even though there's a whole bunch of other atoms in there, because the nitrogen gives it the function. Okay, and the nitrogen being an amine, for instance. Okay, let's look at these, which are organic molecules with these functional groups in we're given the condensed structure. So remember, the condensed structure is just what's bonded to each carbon. So we can build out the structure and circle and write what the functional group is for each of these. So building out the structure this is a carbon with 3 hydrogens. And this is the 4th bond. So every carbon has to have 4 bonds, is to this, which is the functional group COOH. That functional group is called the carboxylic acid. Okay, and so we want to write the structure of that, not just COOH, but it's a carbon with a double bond oxygen and a single bond OH. So notice that the carbon has 4 bonds coming out of it. There are 4 lines. So that's important that that's a double bond and then a single bond. Okay. The next one over is a CO, and that CO is the ketone functional group. So you want to make sure when you're drawing the structure of this, this is a carbon with 3 hydrogens, and then bonded to the carbon with just the carbon double bond oxygen that's in the middle. That's what the ketone is. And this then has a CH3 group. Okay. So this is the carbon double bond oxygen in the middle, and you can add the lone pairs or not. I'm generally not going to add the lone pairs. Just having the functional group in there is what's important on this. Okay. So for this next one, you've got this OH functional group. That's called the alcohol functional group. And so this, building this out, starting from the left, is a CH3. There's 3 hydrogens on the carbon. Then there's a CH2. There's a carbon with 2 hydrogens. And then the structure of the alcohol functional group is you just need to write OH. You can write it the oxygen and then separate bond to the hydrogen, or just OH, and that's okay here. The next one over, you've got that COO. When those 2 oxygens are close together, that's the example of ester, the ester functional group. And so when building this out, this is a carbon with 3 hydrogens, and then a carbon with 2 hydrogens. And then that ester functional group, you don't want to just write COO. The ester functional group has the carbon with a double bond oxygen and then a single bond oxygen. Okay, so that's the ester functional group. And then on the right of that is a CH3. So that's a carbon with 3 hydrogens. Okay. The next one, you've got CH3, CH2, CHO. This CHO, that's the condensed structural formula of the aldehyde functional group. Okay, so when building this out, you have CH3, you have a CH2, and then you have the carbon double bond oxygen single bond OH. So you don't want to write CHO, you want to write the structure of the aldehyde functional group. And so notice here that the carbon should have 4 lines coming out of it, 4 bonds. One of them is a double bond to the oxygen. This next one has an OH in parentheses. That OH is the alcohol functional group. And so this is a carbon with 3 hydrogens, 1, 2, 3. And then this is a carbon with 1 hydrogen. That hydrogen can be up or down. And then this alcohol is on that. So that is the OH group can be up or down. And then this continues to the rest of the molecule, which is a CH3. So that alcohol is kind of like a branch. When you have the branches in parentheses, we saw that in the last lecture, that alcohol group is in parentheses, which is kind of like a branch. It can be up or down from the main chain. Okay. This one, next one, is when you have an oxygen in the middle. That's called an ether functional group. And so this, building this out, is a carbon with 3 hydrogens, then an oxygen, then another carbon with 3 hydrogens. Okay, that's called the ether functional group. And then the next one, you recognize the CO, that's the ketone functional group. And so in building this out, that's CH3, and then a CH2. And then that ketone functional group, you remember you want to have the carbon double bond oxygen that's in the middle of the chain. And then the next you have a CH3. Okay. And then we have, this is a CH3, CH2, NH2. When you have a nitrogen, anytime you have a nitrogen, this is going to be an amine functional group. So this, building this out, is a CH3 and then a CH2. And then the nitrogen has 2 hydrogens on it. Nitrogen has 3 bonds in a, make sure that doesn't look double. Nitrogen has 3 bonds and 1 lone pair for its octet rule. So you don't need to have the lone pair. I'll actually erase that to be consistent. But carbon has 4 bonds, nitrogen has 3 bonds, oxygen always has 2 bonds, and hydrogen always has 1 bond when you're drawing these structures. Okay, and then let's take a look at this Last one. When you have the name of the organic molecule, you can write the structure by basically picking out all the parts, just like we did when we had the structures last time with branches. So what we'll have this time, though, is the name endings, which indicate a functional group. So these are functional groups as the name endings. So starting from the right side, just like we did last time, but now you have the name endings, which will be a functional group. This OL means there's an alcohol. And when you have a functional group, you need to know the location by looking at the number at the front of it. So this is an alcohol on carbon number 3. That's what that 3 is. Now the rest of this name is pentane. So that means it's a 5-carbon parent chain. So in building this, you need 5 carbons, 1, 2, 3, 4, 5, and then you want to number it. And you get to choose the numbering left to right or right to left anytime you're building the structure. So the 5-carbon parent is only needing, there's no branching going on. There's no double bonds, no triple bonds, because they're all single bonds. That's what the ANE means. Okay. And then you need the alcohol on carbon number 3. So put an alcohol group, which is OH. Once you have fulfilled everything as part of the name, then you just need to fill in the rest with hydrogens so that every carbon has 4 bonds coming out of it. So make sure that your hydrogens complete the structure. So add enough hydrogens so that every carbon has 4 bonds. And there's your structure there. For the next one, we've got butanoic acid. So when you have the oic acid name ending, this means it's a carboxylic acid. And we need a location. When you don't have a number at the front, see there's no number at the front of this butanoic acid, it must mean that you have it on carbon number 1, because you can take away ones or you can put ones in, and that's what we're going to do, put in the number 1. And then this AN means all single bonds. And then this but means it's a 4-carbon parent. Okay, so build this. You want 4 carbons, 1, 2, 3, 4, and then number those carbons, 1, 2, 3, 4, and then add on the carbon number 1, the carboxylic acid functional group. So the structure of the carboxylic acid functional group is a double bond oxygen and single bond to an OH. Okay, and then that's everything on there. So you want to make sure next that every carbon has 4 bonds. So this already has 4 bonds in carbon 1. Carbon 2, you're going to need to add hydrogens to 2 and 3 and 4. Okay. Sorry, I'm going a little bit over. We're almost done, but we'll get it all in. The next one is methanol. So the name ending is AL. That's an aldehyde. So the aldehyde, you need a location for the functional group. And if there's no number at the front, it must be in carbon 1. Methan, so AN means all single bonds. And meth means a 1-carbon parent. Okay, so 1 carbon, that's easy, just 1 carbon. And you want to put an aldehyde group on that 1 carbon. So I don't need to number that, but I do need to put the aldehyde group, which is a double bond oxygen, single bond hydrogen. Okay, don't add any other carbon to it. Okay, so that means just finish this out by adding a hydrogen to it so that the carbon has 4 bonds coming out of it. The next one has a slightly different name ending, methanol, OL. So that means it's an alcohol. And again, there's no number at the front, so it must be on carbon number 1. But this AN means that they're all single bonds. And you guys might notice that all single bonds excludes any double bonds that might be in the functional group. And the meth means it's a 1-carbon parent. Okay, so building this, you've got your one carbon. You want to put the alcohol group on it. It can be up, down, right, or left, but the alcohol is an OH on carbon 1. I don't need to number this. I don't want to add any other carbons. The only thing I need to add is enough hydrogen so that there are 4 bonds coming out of that carbon. And then it looks like we're at the last one, which is 3-hexanone. So you've got the name ending ONE. That means it's a ketone. So the ketone does have a location this time. It's on carbon 3. Okay, so going backwards from the name, AN means all single bonds. And hex means that it's a 6-carbon parent. Okay, and then that 3 is the location of the ketone. So building this now, you've got 6 carbons, 1, 2, 3, 4, 5, 6. And then number these 1, 2, 3, 4, 5, 6. And put a ketone on carbon number 3. So a ketone group is the double bond oxygen. Okay, ketone groups are common in stored fats, and that's the ketosis diet that I mentioned in the video. And so that's where it comes from, ketone. Okay, so I got the ketone on carbon number 3. Everything is fulfilled. So then that last thing you need to do is make sure that every carbon has enough bonds on it and make those bonds to hydrogens. Notice that ketone group with the carbon already has 4 bonds, so I don't need to add anything to it. But these other carbons with all single bonds need hydrogens. Okay. Okay, so note, I had to fix this. This is not an alkane. It's an alkene is the double bond. The name ending ENE is the double bond, and YNE is the triple bond. ANE is when you have all single bonds.